In this lesson, we'll look at some theorems that relate to isosceles triangles, beginning with Theorem 20. If two sides of a triangle are congruent, the angles opposite the sides are congruent. And notice we have a way to abbreviate it with pictures, and it's often just said for short, if sides, then angles. And the proof of this theorem is fairly short. We'll start with the setup. The setup says that we start with an isosceles triangle, and by definition that means that the two legs are congruent, in this case AB congruent to AC. And we're going to try to prove that angle B is congruent to angle C. Well, let's mark up what we know. We know that AB is congruent to AC, and our strategy for this proof is to prove that this triangle is congruent to itself, or more specifically, congruent to a mirror image of itself. So let's make that mirror image. And notice when we did that, the letters B and C are backwards, or they're mirror images. So we'll flip them around. They don't need to be mirror images. We label this triangle ABC. It wouldn't matter if we also labeled it ACB, that they would still be congruent to another, because, of course, AB is congruent to AC. And so that's the first thing we're going to write, is the given, that the two legs of the isosceles triangles are congruent. And what's interesting about statement 1 is it proves that AB in the left triangle is congruent to AC in the right triangle, but it also proves that AC in the left triangle is congruent to AB in the right triangle. So that statement actually gives us two pairs of congruent sides. And then, of course, BC is congruent to itself by the reflexive property. And now we have that those two triangles, the original triangle and its own mirror image, are congruent to each other by side, side, side. And if they are, then angle B is congruent to angle C by corresponding parts of congruent triangles being congruent. The converse of Theorem 20 is also true, and it's going to be called Theorem 21. If two angles of a triangle are congruent, the sides opposite the angles are congruent. And we can also shorten that theorem with a couple of pictures, and that often is read, if angles, then sides. I'll set it up, but if you'd like to stop the video and do this proof yourself, it's very similar to the proof for Theorem 20. There's one major change in step 3, and I'll give you a moment to stop the video, and then I'll show you my completed proof. And here's my completed proof, and you'll notice the biggest difference is in step 3. The reason the mirror imaged triangles were congruent was ASA, and in the first theorem, the reason was SSS. Among the things that these two theorems tell us is, if at least two sides of a triangle are congruent, the triangle is isosceles, and if at least two angles of a triangle are congruent, the triangle is isosceles. Well, the inverse of Theorem 20 is also true. And it's been a while since we talked about inverses, but let's read the inverse of Theorem 20. If two sides of a triangle are not congruent, then the angles opposite them are not congruent, and the larger angle is opposite the longer side. The last part, where it said the larger angle is opposite the longer side, is not exactly part of the inverse, but it happens to be true. And the inverse of Theorem 20 becomes its own theorem, which will be looked at in more detail in a later lesson. And notice the little pictures we've drawn at the very bottom as a way to abbreviate the inverse of Theorem 20. And that could be read, if not sides, then not angles. And it also applies for Theorem 21. The inverse of Theorem 21 is, if two angles of a triangle are not congruent, then the sides opposite them are not congruent, and the longer side is opposite the larger angle. And again, this is its own theorem, and we'll look at it in more detail in a later lesson. And also, the pictures could be read, if not angles, then not sides. And we'll do one sample problem that uses some of the theorems, definitions, and postulates that we've looked at recently. And we're going to prove that the median to the base of an isosceles triangle bisects the vertex angle. So here's the setup for that proof. We have an isosceles triangle with a median drawn from the vertex angle A down to the opposite side, which is called the base. And of course, By definition of median, point D is the midpoint of the base. Well, based on all of this, let's mark up what we know. Well, we know that AB is congruent to AC because if angle A is the vertex angle, then the two sides of that angle are the legs, and the definition of an isosceles triangle is that the two legs are congruent. We can then mark those two angles, angle B and angle C, congruent because if sides, then angles. And then because we know what a median is, D is the midpoint of BC, so BD is congruent to DC. And you can see we now have a side angle side situation in triangle ABD and triangle ACD. So now we have our strategy for the proof. Let's see if we can lay out the reasons. We state the given that we have an isosceles triangle with vertex angle A. And then we state that AB is congruent to AC because legs of an isosceles triangle are congruent. You could also write definition of isosceles triangle. And now I'm going to show you another technique that a lot of folks use. We've written the letter S with a circle around it. And that shows that in step 2, we've proved a pair of corresponding sides congruent. And then in step 3, we have that angle B is congruent to angle C because if sides, then angles. And we write an A by step 3 because that's a pair of congruent corresponding angles. Now in step 4, AD is a median. That's given. We don't write anything by that yet, but we're going to use that so we can get one more pair of congruent sides. And then we write that D is the midpoint of AD by definition of the median. Then we can say that BD is congruent to CD because that's the definition of a midpoint. And now you'll notice our technique. We have an S and an A and an S. That's side angle side. So we've proved two triangles congruent by side angle side. And of course our job was to prove that angle BAD was congruent to CAD, and they're congruent by CP, CTC. In this lesson, we were introduced to Theorem 20. If two sides of a triangle are congruent, the angles opposite the sides are congruent. For short, if sides, then angles. And also, the converse of Theorem 20 is true, and it's its own theorem. Number 21, if two angles of a triangle are congruent, the sides opposite the angles are congruent. Or for short, if angles, then sides.